Today we will be adding a flow and temperature monitor to our PC. This is the flow meter that we got. It is a, how do I pronounce that? Bykski, and found it on Amazon. So I guess we will open it up and take a look at it. Comes in a nice plastic box. This has an OLED display and very simple. Just plug in power and it's just a display. This is directional. It does have an impeller in there. I tried to find one that did not have an impeller in it with no moving parts, but they were relatively expensive. So this one looks like it'll do, and this does have a flow direction, so if we want to reverse the direction, we'll have to read the instructions and see which direction the flow is supposed to be. And I think we can take one of these parts out and swap some stuff around to reverse the flow if we like. So first of all, let's see what direction the flow is set to at the moment. Looks like it is set to in and out here. So if you want to change that, there's supposedly an adjustment tool which is not included to change this. So I'm going to look around and see if I can find a hex key to unscrew this thing. I'll be back. Well, after digging around for the correct tool, comes to find out I don't think I will need the tool after all, because I believe, according to the instructions, it is already set up in the correct direction. But I will have to get one of these 8mm hex wrenches. This looks like something that I should have. It'd be handy to have around. Anyway, I will have to pick one of those up when I'm at the hardware store next. But for now, I guess, well, since we don't set up correctly, we don't need these anymore. Throw the box aside. And we've got some more connectors. I happened to find off Amazon, but they weren't too expensive. I found some couplers that actually swivel. So now when I screw this valve on, so I found a valve for the drain port on this thing. So now I have a valve to control the output to replace that leaky Corsair valve. Now I did actually take that back, and I got I exchanged it for another part. But anyway, so I got a valve, a cheaper valve off Amazon. So I put this in, and these swivels will be handy because now I can position the valve in the correct direction I would like. So let's get the case. Let's get set up to work on our case. What I would like to do first is we will have to drain this so that we could put this flow meter in line here, and I'm thinking of putting it in line right here. It's not that heavy. I'm a little nervous putting it on here so that it doesn't put a leverage on this connection here and cause it to leak or threads to get damaged in this plastic fitting. But I guess the only other option would be to put it somewhere up near the top, which is more difficult to route through. I mean, we change it up later. One thing nice about a custom loop, you can change all this up at a later time. So first of all, let's get the valve installed. And for that, we have one of these swivel fittings. And then I have a small piece of tubing to put on the end of that so we can drain it in here. I'd like to recover and save as much of this distilled water as I can, because I only have so much of it. We will get one of these ready for our tubing. and we'll get that installed later. So this thing currently has water in it, and a trick with this is if this is sealed up here, we can actually remove this down here and not too much water will spill. And the reason for that is because when the water comes out here, something will need to replace the volume here that the water is taking up. So as long as we don't open two ports on the system at the same time, the water should not flow, at least very quickly, out of this port down here. It's still going to drip, but as long as we do one at a time. But when we install this, we will have to take off this connection. We will have two openings on the loop here, and water will come out definitely. So we do need to drain this down. So I would like to see if I can quickly install this valve. I kind of like that Corsair valve, but I mean, this one, if it turns, this one's not bad. I mean, it doesn't stop. It's just continuously turns. As long as it seals, it's good. So we will put the swivel on here. And sealing surface looks okay. And the reason why I'm putting this swivel on here is so I can position the valve here where I would like it, because we won't, unlike pipe threads, we can't keep torquing this thing to get the valve lined up the way we want. So let's take this off and hopefully we don't spill too much water. A little bit's dripping out, not a lot. Okay, we lost a little bit of water. That's okay. Now, question is, oh, this valve is open. Okay, so we're sealed. Oh, there are bubbles. And I'm worried if this connection here gets too heavy, is it going to leak or damage the seals in there? Hopefully not. I mean, I could drain it out like this, but give me a little more room to get the something under to catch the water. So we'll throw this extra piece of tubing. Okay, now if we open this, so I need two hands for this valve, and there's barely any flow coming out of this, but if we open the up top here, it'll really start to flow out once the air gets into the system. All right, I am going to seal stuff back up. And I'm going to put this water back in. Surprisingly, this does not take that much water. I mean, it's not even 500 milliliters. So the next step is, I don't know how much drippage we're going to get here. Hopefully not a lot. Oh, none. Okay. So next step is we're going to put this in line. So we have another swivel. That is just sealing on this plastic. Hope that works out. Okay, that looks good. Don't forget our ring. Well, this is kind of wobbly, but we'll see how it goes. I mean, I was always curious how much water flow we were getting and how much pressure. I don't think it's going to show pressure, but the temperature and the water flow. So it'll be nice. Looks like it's powered with the 5 1/4 drive connector. So I'll have to grab another adapter. Now, let's see if everything is nice and tight here. This is really spinny. Gosh, the more fittings, the more of a chance something's going to leak. Okay, we learned from last time that if we're going to fill with the funnel, it's going to make a mess if we try to fill it at an angle. So we'll just unscrew the top and just put the water directly into the top here. There's our funnel and all that water that we drained out earlier. Okay, we are full. So this last bit of water, I'll have to add that after the water circulates. I think that's cross-threaded. Let's not cross-thread this. All right, that's much better. I wish this LED connector was not here. I wish there was a way to position the LED connector where you wanted it, but apparently not. So also, let's remove this and put our plug back in because like I said, I don't trust these valves. Now we got a valve plus the plug. Yeah, this is a little flaky. Might have to come up with some way to secure this somehow. It'll work for now. I will be back with the power supply to power this up. Well, we are looking at the back side of the case. So I dug out a power cable because I don't have the correct number of adapters to plug in another one of these Molex connectors simultaneously to my test power supply that I've got. I have a, show you this. So this came with one of those USB to 3.5 inch hard disk adapters. And it's cool because it's 12 volt, 2 amp supply and it can power this pump. without having the actual computer powered up. So I was going to use this, but I don't have a Y adapter to plug in the pump and the display at the same time. However, when I went to wire it up to the actual power supply, take a look at this connector. This is an inline connector. See, there's the in, there's the out, or the other way around. I did not have to get a Y adapter because this plugs in line. So this is even better. So we'll just, I will have to neaten this up. Still need to work out this wire mess. But if that's the case, then this just plugs in here. You know what? I needed this anyway because this display is 5 volts. This 12 volt adapter I have would not have powered this thing. So the display runs on 5. The pump runs on 12. And yeah, we all know these Molex connectors have both. If I can get it connected, this connector does not want to go in. Oh. Is that going to work or not? Dude, yeah, this isn't going to work. Only the 5 volts goes through to the other side. See those connectors? The 12 volts doesn't come through here. Who thought of this? I mean, this was a cool idea, but not when it doesn't pass the 12 volts also for the pump. Okay, back to our original solution. So plug the pump back in, and then we will get, we've got one more SATA power here. One is on the fans, another one's on the pump, and we've got one more here that I can use for the display. I've got to clean this up later. This is turning into a mess. Which way do we go? This way, it looks like. All right. Now we've got 5 volts for our display. It's a lot of work. All right, turn this guy around and power it up. This thing's getting heavy. Just a minute, go grab a power cable because I don't have a power cable here. Actually, yeah, I'm gonna grab the power cable. All right, connecting power. And our pump's going to have a bunch of air to flush out in the system to maybe readjust the camera. Okay, hopefully that's a good view of everything. So we'll power this up. Yep, here goes our air. And our display. So let me move the camera in on the display. The pump is extremely noisy now because it's flushing out the air. But that's nice. We have 4 liters per minute, 29 degrees Celsius. So let me give it something to do here. I will give it something to build. So let's have it build Firefox again. Typing one-handed is fun. Okay, it is loaded down with stuff to do, and actually the compile hasn't quite started yet. It's still pulling in sources. Oh, temperature spiked up to 77 degrees, so temperature on this fluid with water should hopefully go up. See how hot it will get. So let's see, if I restrict the flow, let's see if this thing is working. Oh yeah, 2.5, 2.6. I bet you this thing would perform a whole lot better if I got the air out of this. The problem is I've got the pump tied into the system power, and it's not easy to, actually no, I can disconnect it. It's just that one connector on the back. We reach behind there, and I will turn off the pump for a second so that it flushes that air out. Yeah, well, the system's loaded down. This is a really smart idea, but all right. Temperature's still okay. We didn't go above 78, so yeah, it's going to take a while for these bubbles to work out. Anyway, so there we have it. There's a installed a flow meter. Okay, now that the system's been running a while and most of the air has been flushed out of the system, we can see the flow rate has gone up quite a bit. We're sitting around a 5.5, 5.3, 5.4, 5.2-ish. And if you listen very closely, now it's quieted down, you can actually hear, I hope the mic picks this up, you may actually be able to hear that impeller turning in there. It sounds like a small electrical arc, but I'm pretty sure it's that impeller, and that's how it senses the flow. So after setting this up and getting some experience with it, I guess go over some advantages and disadvantages. The advantage that I see is that it's very easy to set up. I mean, you just plug it in and plug in the power, and I mean, you're good to go. There's no software set up, nothing to configure on it. It just works out of the box. However, the disadvantages, that also brings up the point that since it does not connect in with any kind of software, it does not have any kind of a sensor output to connect in with software. So if you're looking for a sensor that you can monitor and tie in with the software monitoring package, this is probably not the one to look for. The only connection is the 5-volt power, which brings up another point, is this splice here, this inline splice connector. I mean, this was a great idea, and it would have been nice. I would have liked to use it, but it does not pass the 12 volts through. If a lot of people like me use pumps that require 12 volts, this connector is not going to pass 12 volts through for your pump. So that's something to think about. And also, I lucked out that the flow direction that this flow meter is set up for was correct for my setup, but it is possible to actually change the input and the outputs and reverse them, but it requires, like I mentioned earlier, an 8mm hex wrench to unscrew the plug on the end here, and once that's unplugged, you can pull the impeller out, flip it around, stick it back in, and now your inputs and outputs have been reversed. It would be nice if that hex tool was included or something in some way to be able to open this up, because I don't have an 8mm hex tool on hand, and I think I'm going to be picking one of those up pretty soon. And one other thing I'd like to touch on is the OLED display. I mean, it's nice, it's pretty, but these OLED displays may fade over time. I do have a mini disc player that has the same style of OLED display, and it has faded over time, so I'm not quite sure how long this display will last before it starts fading, but that's something to watch out and be careful for when you buy products with OLED displays. It's, I mean, only time will tell the quality of the display and how long it will last, but that's just something else to think about. So anyway, those are the thoughts on this I still can't pronounce this, Bykski temperature flow meter. It's a part number B-TFC-CS-X. So anyway, hope that was useful, and we'll see you guys on the next one.